So we know some derivative rules. We know the power rule, we know the derivative of e to the x, we know the derivative of natural log of x, but now we're going to get into a few more examples. We're going to learn a few more derivative rules here. We're going to start with the product rule. So we talked in, I want to say it was section 2.5 about sort of ways to get around multiplication, and here we go a little bit further into that. If we're multiplying two functions, how do we take the derivative? So if we have f of x times g of x, then y prime, the derivative of this, is f prime of x times g of x plus f of x times g prime of x. Sometimes more simply, I'll put this as, and I'll try and color code these as well, f prime times g plus f times g prime. So this is the power rule. This is usually the one that I look at right here. And I would recommend memorizing this. This is something that you will have to know. If you're curious about where this comes from, there's a ton of videos out there that show proofs of this, but I don't want to get too bogged down in proofs in our class here. So we're just going to practice utilizing this product rule in this video. So for starters, I have part A here. I have y equals 3x plus 5 times x squared minus 3. So I could go and FOIL this out, and I may even just show that I do end up getting the same answer here, but I want to practice using the power rule. The first thing you want to do is you want to identify which of these functions is f of x and which of these functions are g of x here. So I'm going to call this first function right here, I see 3x plus 5, I'm going to call that f, and then I'm going to call x squared minus 3, how about I call that g? And when we were very first starting these, I think one really helpful thing is off to the side, I'm actually going to go and say f is equal to 3x plus 5, and g is equal to x squared minus 3. So I need to know for my power rule here, or excuse me, my product rule, I need to know f prime and g prime as well. So I'm going to go find each of those. So f prime is just the derivative of 3x plus 5, which in this case is just 3. And g prime here, derivative of x squared minus 3, that would just be 2x. After that, I'm just going to go ahead and plug everything that I have here into my product rule. It's pretty straightforward. And so here, let's start with f prime. F prime is 3 times g. G is x squared minus 3 plus f, I'll have 3x plus 5 times g prime. G prime is 2x here. So what I have, I've got f prime times g plus f times g prime. I'm just utilizing this formula here. Don't overthink it. One other thing I've seen some students have success with is if you like this method of listing out all of your functions and their derivatives over here. Look, notice this. Here I'm going to take f prime, I'm going to multiply it by g, and then I take f, I multiply it by g prime. Sort of like a cross multiplying, but not really. I'm not really a big fan of that term, but it does sort of make sense here. We're just multiplying the original function times the derivative of the other, and vice versa. So we're taking f prime times g and f times g prime. And once you have all of that set up, it's just a matter of taking this equation and simplifying it. So I'm going to distribute the 3, so I have 3x squared minus 9, plus now let's distribute the 2x. I have 6x squared plus 10x. We'll combine like terms, so I should end up with 9x squared plus 10x minus 9. Here is my derivative y prime. So for the most part, once you identify f and g, it is just, hey, take what you've got and plug that into this formula. There's really not a whole lot of tricks here. I think the difficult part of the product rule is identifying when you need to use it, because it can be very tricky, and it's going to be a little bit subtle. It's going to be a little bit tricky, especially when we start to talk about more and more derivative rules. We're going to add more and more in. We've got 2 more to learn after this. So just to show that I will in fact get the same thing, let me erase this. I'm going to show that even if I were to FOIL this out, if I was to FOIL this out, I'd have 3x squared minus, what do we've got there, 9x plus 5x squared. Oops, excuse me, no, I made a mistake here already. I would have 3x cubed minus 9x plus 5x squared minus 15. And if I took the derivative of that, y prime, that would be 9x squared minus 9 plus 10x. Oops, minus 9 plus 10x. So I end up with exactly the same derivative. So sure, in cases like this, you could fall back on the workarounds that we talked about in Chapter 2. But unfortunately, that's not going to last us very long, because then we're going to come across functions like part B right here. Here I have y equals 3x times e to the x. There's really no way for me to simplify this any more than it already is. It's just not a good way to write it. So I'm going to, just like last time, off to the side, say here's what f in this case I'm going to pick to be 3x, which means that f prime will just be 3. G will be e to the x, so g is e to the x. G prime, the derivative of e to the x, well, that's just e to the x. So keeping in mind my product rule, remember, I'll write it right here so we have it in front of us, f prime times g plus f times g prime. So f prime is 3, times g is e to the x, plus f is 3x, times g prime is also e to the x. And I can't really simplify that much more. I guess I could write this as 3e to the x plus, not even, that's just, I have uncolor coded my answer. So you could leave your answer like this. One thing I would like to get a little bit of practice with is factoring these expressions, because as we work with these later on, in the next chapter, we're going to still be taking derivatives, but then we're going to be doing some algebra with them as well. So I might want to take this and set it equal to 0. I might want to work with this algebraically, in which case the factored form of this might be a little bit easier to work with. So if I wanted to factor this entirely, I see a factor of 3e to the x in each of these terms. So that means I could factor out 3e to the x, and that will leave me with 1 plus x. Do you have to factor? No, absolutely not. But I think it's a good skill to start practicing, because there will be problems where it will be very, very helpful for us to factor. So I would say either of those forms are perfectly fine here. Part C, I have y equals negative x squared times natural log of x. So again, I'm going to be very careful. I'm going to try and separate my functions. My f, that first function, is going to be negative x squared. So f is negative x squared. F prime is negative 2x. So g, that leaves me with natural log of x. G is natural log of x. G prime, derivative of natural log of x, is 1 over x. So let's use our product rule here. Y prime is equal to f prime, that's negative 2x, times g, that's natural log of x, plus f, that's negative x squared, times g prime is 1 over x. And let's just section this off so that we don't get mixed up. This one I can do just a little bit of simplifying with this term right here. I can go ahead and cancel a factor of x. When I do that, I'll have y prime equals negative 2x natural log of x minus x. We could leave our answer like that, or we could factor out to see a common factor of x, or even let's factor out a negative x just to make it look a little bit nicer. And that will leave me with 2 natural log x plus 1. So again, either one of these would be perfectly fine as your solution. I don't care whether or not you're factoring these out, but I do think it's a good idea to start practicing these now. As we progress further and further with our product rule, and as we are adding in more and more derivative rules, I probably won't stop to label here's what f prime is, here's what g prime is. So I'm going to show you what an example of that would look like here. I will still try and color code them right now just because we're still learning this. I think it's helpful to see. So if I'm looking at part D, I have y equals e to the x times natural log of x. So I see this is my f, this is my g. Let's get to it then. Y prime, derivative of e to the x, so the derivative of this guy would just be e to the x, times g. I'm going to leave natural log of x alone, so that'll still be natural log of x, plus f, so I leave e to the x alone this time, it's still just e to the x, times g prime, derivative of natural log of x, that's 1 over x. Honestly, I think I could probably just leave my answer here. The only way I could really simplify this if I wanted to, I could say e to the x times natural log of x plus e to the x divided by x. Or if you wanted to factor, we could factor an e to the x. Either one of these, you could kind of make this jump. You could say, well, this is e to the x times natural log of x plus 1 over x. Again, I don't have a strong preference about which of these that you use, but I do think that it's a good idea to be practicing your factoring, because I think that's going to be a really important skill in the next section. So, like I said earlier, I probably won't be labeling here's what f and f prime and g prime is every single time. If you are not quite feeling comfortable with the product rule, if you kind of feel like you need to take your time and label those out, then by all means, absolutely 100% continue to do that. It's a good way to check your answer, and I think it's a good way to organize your work. And I will never ever argue, and I will never ever say don't do that, you're doing too much work. No, I'm going to say yes, you should continue to do that as long as you feel it is necessary. But if you feel comfortable skipping this step, then by all means go right on ahead.